and what processes are controlling the emission of carbon dioxide and the amount of carbon dioxide in our atmosphere over time.
The ocean moves, rising and falling, circulating energy and nutrients. As the Earth warms, oceans actually expand. Sea levels rise. And should polar caps and glaciers continue to melt, the total quantity of water contained in the world's basins will continue to swell. But how much? And to what end? In 2008, the Ocean Surface Topography Mission will begin looking for answers.
We're going to be able to use that data to update all our models for example, weather prediction. And one of the things that we want to use on a day-to-day basis for that are for helping us understand and predict events like hurricanes.
For the first time, mankind has the ability to look at the global change of the ocean. Such great area, 70% of the Earth, now revealed from space. We will have a climate data record allow us to see the future and make preparations.
Frozen world, the cryosphere, the austere and spectacular North and South poles. NASA visits every day with one-of-a-kind satellites like ICESat and GRACE, capturing data about change over time. But the future demands an understanding of the past and a clear view of the hidden present. So in 2008, we're going to do what we're famous for. We're sending a scout to check it out up close.
What's happening in Pine Island is potentially of tremendous consequence to the entire planet. What sea levels do in the future may be very much tied to what's happening in this little spot on Earth. We marry the satellite observations that we do so well at NASA with up-close observations of real detail that we can do so well in the field.
The changing Earth, dynamic planet, home. Gathering data on location and flying above, this is world-class climate science. Understanding Earth's dynamic climate defines a fundamental pursuit. We search, we strive, we quest for understanding. Exploration begins the moment there are questions to answer, and make no mistake, we are the world leader in Earth science research. Of the many colorful planets in the solar system, it's the sparkling blue and green one that binds us all together. In 2008, we push back the frontiers of that planet just a little bit more.
Okay, well, I'm going to make some closing remarks, and then we're going to have a chance to take your questions. I just want to say a few things. The first, you heard Dwayne say at the beginning, our science never sleeps. Well, you could tell from the graphics what Dwayne and his team put together that Dwayne never dozes. And we want to thank him for the efforts and these great graphics and videos that he put together. Secondly, I hope that we accomplished our purpose, which was to show you what a broad and deep program NASA already has in the earth sciences. And we hope whether you're here in the room or whether you're out in TV land that you really learned something from this presentation that you didn't know about the scope of our program. But that's not enough for us, and it's not enough in two different ways. First, we know that we can do better. We can have a better earth science program. And over the next several months, as Mike and his team in the Earth Science Division firm up their plans for executing on the Earth Decadal Survey, you'll be hearing a great detail about the specifics